couple of people who were unable to make it, and there's quite a few who's had illnesses in the family. Looks like quite a crowd tonight. Anyway, that's me, and I'll hand over to John Parker.
Okay, first of all, some apologies. This is not a new talk. I do have a talk which was on the program for me to present later in the day, so you're going to hear from me twice. This particular talk I actually gave in Brisbane about 11 years ago. So I'm going to run through some of this quite quickly, because if nothing else, it may be of some interest that in 11 years a few things have changed. And the slides you're going to see are all produced 11 years ago, with the exception of some that I've added in towards the end. The great advantage of DCC is you are able to control that train rather than the track, which of course is what we've always done in the past. And you get all these bonuses as well, sound and also lights and a variety of animations that are possible. Assumptions were we needed an operating DCC system at that time, something that worked. We need a length of track. We need an operating locomotive, in this case just a DC locomotive to demonstrate it, and a DCC decoder. Now here's a fairly typical wiring diagram of that time. It's a very simple installation which just shows the configuration of a Soundtrax decoder, and here's an ESU decoder also of that time. Once again, this is a non-sound decoder. So if we take a piece of track, just a blank piece of track, and a DCC system of some sort, in this particular case it was an NCE power cab, and we get some sort of mechanism that you want to run on it, to try out this whole concept of DCC. We've got these three items then. We've got the DCC system, we've got a piece of track, we've got a decoder. So how do we connect it? Well, we connect the sections which would normally go to the track. You connect directly to the power system, to the decoder. You'll notice the decoder isn't on a product, it's just sitting on the bench. And then you connect the connections that you would normally connect to the motor, you connect those to the track. And you can see the whole point of this. It now essentially means that any DCC locomotive you put on that single piece of test track will operate as if the decoder had been put in. It's simply a way of demonstrating to people how easy it is to configure something. Ultimately, if you're going to run it as an individual locomotive, obviously the decoder is in the locomotive. And that brings up a whole question of selecting decoders. And there's a number of assumptions that one has to make here. So why would you select this decoder over that decoder, a particular type? And one is the current consumption, and particularly the stall current. However, I would argue that in fact the maximum current of a stall motor is at the point when the wheels slip, because on a model you don't ever get to a situation where the wheels necessarily stall on their own, they will slip on the track. Now that figure is slightly less. I'm getting checked over here, which is great. Fact checking going on over here. And that figure is slightly less. So the stall current of wheel slipping is probably useful enough. Modern motors in steam locomotives that we're building, even in O-scale, are generally a maximum of 1.1 amps, often a little bit lower than that. Whereas most of our diesels have had slightly larger motors, some up to 3.5 amps, although many diesels now also only take 1 amp. The two most common are those from either ESU or Soundtrax, although a number of people also use decoders from other sources as well. So you don't have to be those two companies. It's just the two I've used more than any others. Decoders have changed over the years into different versions, primarily because of what was happening in the mobile phone area, because the components that are used in decoders tend to come from that area. So if there are major changes in phones, it's reflected in later generations of decoders. Now, I made the point at that time that for many decoder manufacturers, documentation was a bit hit and miss. There wasn't a lot around. But fortunately, that was never true for ESU log sound. They've always had pretty comprehensive documentation. and all of it's available online and available to be downloaded free of charge. This was not 11 years ago. This is now, because of course now there's another choice. There is another choice, the ability of having a decoder which works in a somewhat different way. It has all the DCC features, but also can be operated via the use of a phone, either an iPhone or a Android phone, and gives you the whole range of DCC features, but packaged in a quite different way. It's very similar to a standard soundtracks decoder of that time, of now, but has Bluetooth configuration to operate it. So what do you need if you're going to use a Blue Nami, which is a different way of getting into DCC? Well, you need a piece of track, you need a locomotive, you need the decoder, of course, you need some power on the track. And an old PC power pack is a great starting place. You need 12 to 20 volts, anywhere within that range, to power the track. You need a phone, or an iPhone, or an iPad, or an Android. The one thing you don't need is a DCC system. And one of the bonuses that comes if you're going this way is you can do all of your programming via the app on your phone. So programming now is considerably easier. I think anyone would agree with that. And you don't need any special program. Now you can do, of course, a lot of programming on standard decoders without a programmer. But to do anything of any great consequence, a programmer, such as the log programmer, is very useful. However, with Blue Nami, you don't need to do that at all. Now, this gave you the opportunity to try something much simpler, a much simpler configuration of a DCC control without having to buy the whole DC system. You buy a decoder which is slightly more expensive than a standard decoder, but you're still much, much cheaper than buying a DC system. Now you would need this Blue Nami decoder in every locomotive if you're going to have a lot of locomotives and you want to run them all the same way, so that has some problems, and probably in that case the standard DC system makes far more sense. But if you want to build a very simple layout with perhaps only one loco, this is a great way to go.
So, Bob Gallagher made the remark to me once that anything that you publish is going to be out of date by the time that you've published it, and that has proven true with this talk. So we will start off with the addenda. So one thing that has come to light since I did my original talk is that there are in fact two different colours that we used for the lettering on the colour schemes on the FS cars and on mainline cars throughout New South Wales. So we have found that prior to June 1955, the yellow for the lettering was applied using gold leaf on the transfers, but from 28th of June 1955, all drawings, as you can see in the corner of this title block for 5-inch letters, was amended to lemon yellow as per British Standard 381C-1948. And so here is an example of a car which has the original gold leaf lettering. You can see that it matches quite nicely with the russet, and that's probably why they chose that rather greenish hue for the original russet. Another thing that I wanted to elaborate a bit on was half painting of passenger cars. So a full repaint is fairly self-explanatory. Basically, every 3 years, cars were brought in for assessment, and generally would receive a half paint, and then the third repaint would be a full repaint. This did vary depending on conversions, accidents, or various other factors. The half paints were often used to update signage and other details of the liveries. And although it usually only covered areas requiring work, as an accounting dodge, it could sometimes encompass up everything up to painting the entire car except for the existing lettering. And I've found at least 6 FS cars which were treated in this manner. So here's an example from Graham Belden's film of a half-painted car where they have used it for patch repairs, and one where they have used it for updating the colour scheme from the old Tuscan and Russet with Russet all the way up to the leatherboard. You can see on the ends they haven't bothered to update it, but they have painted the leatherboard along the side of the car in Tuscan red to update it to the 1940 standard. And now, getting onto the FS cars themselves, we have FS 2103, taken in 1977 at White Bay, clearly in Indian red with the 2 buff lines. However, if we go to the car's history card, we can see that the last full repaint for the car was in 1947, and every subsequent repaint for the car is only a half paint. So clearly this car went through and had everything but the lettering that was already on the car repainted. And here is an example from 1964 showing the original gold lettering from the Tuscan and Russet livery, but still in Indian red. We can also see in this shot of FS 2139 the difference in colour between the lemon yellow on the left for the code and number on the left and the gold leaf still in use for the second class signage on the right hand side of the door. I've also found some new information on logos. I've had the privilege of talking to Bill Casley, the former Assistant Works Manager at Everleigh Carriage Works, and he's provided me with some notes that indicate that BS 2167 was the first car to carry a small logo on the end of the letterboard, and that was outshot at the end of October in 1974. We've also noted FS 2143 is carrying a PTC logo on the letterboard, in addition to XFS 2142 and XBS 2158. And we found a new variation of logo where 2 FS cars were carrying the two-tone blue L7 on a white background on the letterboard. And here is the first one. It's an early build FS with the full door thresholds, and it has been rebuilt with rubber-sealed toilet windows. And there's a closer view of it. This wonderful shot was provided to me by Bob Richardson. And then this more obscure shot shows a car leaving Newcastle. Both these were taken in 1976. You can just see the white background of the logo, and as you can see from the lack of a threshold under the doors, this is one of the later build FS's. Now, moving on to modifications made to the cars. So between 1949 and 51, it was decided to fit steam heating to cars used on a number of services, including the Cooma Mail and the Southern Highlands Express. It consisted of an insulated boiler pipe running down the length of the car with flexible couplings at each end to allow through passage. A condensation trap was located under the centre of the car to allow the system to drain, and radiators were fitted underneath each seat. You've got the car numbers there for your reference as to which ones had the system, and it was progressively removed through the 1960s and 1970s. So only one car these days still actually has any steam heating fittings left, and that's Mail Van HKL 360 up at the New South Wales Rail Museum. You can see here the insulated pipe and what's left of the flexible connection on the end of the car. We have the pipe running down the side of the car, and about the midpoint of the car it tucks under to create a low point to go to the condensation trap we referred to. And from that through pipe that we mentioned, you have a line to a radiator under each seat, and you've got a little slide controller that operates the valve permitting steam into the radiator. Another modification was the rebuilding of the 2AJ type bogies. They were originally a leaf spring design, as we saw in last year's talk. After the 2AN equalised bogies were introduced in 1944, Everleigh Carriage Works rebuilt at least one pair as a sample to trial. The modified design was deemed a success in 1945, and the remaining bogies were forwarded to Commonwealth Engineering for conversion over the next few years. So here we've got one of the original bogies showing how they were, and here is the rebuilt version. The equalised beam runs inside the now enclosed soul bar and connects to the two springs hanging down below the soul bar. This design was basically identical to a 2AN bogie, and the only way you can really tell is to look at the number plate on the bogie soul bar. As I noted in the earlier slide, they were rebuilt starting in the late 1960s, early 1970s due to cracking. The problem area was in that diagonal cutout at the ends, and the resolution was to build that up into a straight profile and cutting in an extra access hole to allow for maintenance and repair. Another modification starting from 1966 was fitting of rubber-sealed toilet windows in lieu of the original glass panes. The new windows were also plastic, not glass, and so if you note, they actually yellow over time. We've got a list of cars known to have been fitted, and they were also used in modernisations such as the MFS cars. So here we've got BS 2033 showing the modification, fairly fresh out of overhaul. A further alteration for safety reasons was the relocation of the lamp irons. So as you can see here, the originals on the left were mounted up at letterboard height, and it was necessary to actually have a foot plate just next to the buffer for staff to actually be able to reach up to there. The solution was to mount the new brackets just below the waste rail. This allowed staff to access them either from the shunter step or from the platform, which saved several injuries and near misses as a result of slipping, particularly in poor weather. A handful of cars, sometime around the 1970s, were also modified with 2CA bogies. This was part of a program to release 2AN bogies and 2AJ bogies for fitting to older cars to eliminate the number of types and parts required for maintenance, and also to modernise and eliminate older leaf sprung types. So we can see here FS 2124 with the cast steel bogies. BS 2173 was also fitted with these bogies when it was converted to locomotive test car 1903. As far as I can find, no BS cars were fitted with these in a passenger carrying configuration. And with that, we'll move on to the actual conversions of the cars. So the first conversions were in 1942 for the Army ambulance trains. 4 cars were converted to provide administrative and staff accommodation on the trains. Most of the ward cars for the ambulance trains were actually N-type cars. So BS 2166 and 2176 were used as administration cars, while 2175 and 2171 became the personnel cars.
Evan, just a question, what colour were they painted?
So The first repaint of them was done in white that was slightly killed with a few drops of black to allow it to weather better. They seem to have been repainted about midway through the war, through their wartime service, and received closer to a light grey colour, but it's proving very difficult to distinguish in photographs, mostly due to the quality of them.
Like being black and white photographs too.
Yes. That, and also that we have very few photos of them taken on the same type of film, so it's very hard to compare from photo to photo. Yeah. All 4 cars were returned to ordinary passenger traffic between 1945 and 47. So here we've got the full consist diagram for the ambulance trains. So the personnel car basically served as a barracks for enlisted nurses. The compartment adjacent to the washroom was fitted with lockers in place of the seating, and the remaining 6 compartments became 6-berth rooms accommodating a total of 36 nurses. Both these and the administrative cars were fitted with jumper cables and conduits to permit power supply from a PHG and later LHG brake van that had been fitted with a single cylinder hit and miss generator. So you can see here from the diagram which compartment had the berths and which compartment was fitted up with the lockers. The administration cars were a bit more of an extensive modification. One compartment was converted into a dispensary and the adjacent one to a medical materials store. A further compartment was converted to a reception office, and then a 5th to a linen store. 2 more were gutted for storerooms for soldiers' kit bags, and 1 compartment was left unaltered with 6 seats to serve as a waiting room. Stretcher cases would be loaded directly into the ward cars, but those who could walk on would have to do their registration through the office car. And so here is one of the few photos that we have showing in reasonable detail the FS cars. You can also see that because these cars had roller blinds in order to comply with the blackout regulations, they have had a small border about 2 inches wide painted around the bottom and the uprights of the windows. This was to prevent light bleed from around the roller blinds. The TAM and AB diners in this consist, because they were fitted with louvered shutters, did not require the blackouts. So from here the cars have a pretty quiet life with next to no modification until we get to 1963. In order to try and economise and close some of the railway refreshment rooms, it was decided to introduce a buffet service on some mail trains and express trains. The trains chosen for this were the Glen Innes Mail, the North West Mail, the Brisbane Express and the Brisbane Express via Wallangarra. In total it required 2 buffet cars each for the Glen Innes and North West Mails, 3 for the Brisbane Express and 1 for the Wallangarra service. The conversion involved rebuilding 1 compartment into a small kitchen. The adjacent compartment was opened into a snack bar with 3 bar stools, and you have here on the slide the car numbers which were converted. So here we can see RBS 2161 not long after conversion in 1963. The only real external alteration is a large extraction hood on the roof for the kitchen and blanking out of 2 windows in the compartment which had the kitchen. Here is the diagram for these cars showing exactly the relationship between the extraction hood, the blanked out windows and the kitchen itself. And here we have an interior view of the buffet in RBS 2161 and the kitchen. As you can see, it's a rather cramped working space to say the least. So these cars proved a success, and particularly on the Brisbane Express via the North Coast. And this actually brought about demand for cars with a larger kitchen and buffet servery area. So the revised layout resulted in a more substantial external alteration. We had three compartments are removed. 1.5 of those compartments are given away to the kitchen, leading to 3 windows being blanked out, while the other 3 are given away to the snack bar. These cars also had the snack bar wrap around all 3 sides of the compartment space rather than just along one wall, which required shortening of the 3 windows that were retained in the snack bar area. You can see how that is all laid out here. And we also have the original railway perspective drawing. Very, very rare that we ever actually find any of these drawings. Most of the drawings that we find are just your normal plan and elevation views. And so here we have one of the very few photos of the interior of the snack bar area. And I'm sure some of you are wondering why these 2 men are in white jumpsuits. We will get to that later. The next modification came in 1962 with the desire to withdraw steam from the Cooma Mail, and the decision was made in order to remove steam heating from that train. They would fit electric heating with power supplied directly from the generator on the locomotive. Initially, like with the steam heating cars, no code change was made to designate them, but in 1967, introduction of 415 volt AC electric heating from the power van on other cars required them to be distinguished so that, well, nobody let out the magic smoke. You have at the bottom of the slide a list of the cars that were fitted up for electric heating, and here we have the diagram of how the conduits were to be laid out. You can see that the fuse and junction box to go to the heaters is only located on one side of the car, and the conduit down the opposite side of the car actually ducts under the car to meet that junction box before reappearing on the other side. So here is XBS 2162 showing the side without the junction box, and FS 2021, and you can see the junction box just below near the handbrake. So as I said, in 1967, electric heating was extended to the Kosciuszko Snow Express specials. The loco heating did not prove particularly successful. It proved to be a significant current draw which limited the power output of the locos and also resulted in difficulties with loco availability, keeping those locos that had been modified with the jumpers for electric heating actually available for those passenger services. Instead, they tended to keep disappearing on freight and unheated workings. So, as I said, the EFS code was introduced to distinguish this one 415 volt car from all the other 750 volt cars. And here it is. You can also see that this car, the junction boxes are in the quadrants at the ends of the car, and there is no duct under. That is the one giveaway to this car against all of the other electrically heated ones. So we then move on to 1974-75. The end platform fleet is falling apart, and the Public Transport Commission is finally forced to pull as many of them out of traffic as they possibly can, which, with the delays to the introduction of the double-deck interurban cars, resulted in country cars having to be cascaded down into interurban service, which is where we also get a large chunk of the rationalisation of country services in the 70s. The corridor layout of those cars proved atrocious. It resulted in long dwell times due to the narrow corridors, and to resolve this, RBS 2161, after having had an accounting swap of numbers with RBS 2170, was rebuilt with a trial saloon layout fitted with Hale and Kilburn seats reclaimed from reclaimed from either end platform cars or Bradfield electric cars. And so here we have IFS 2170. The car has had on this side a water cooler fitted where the window next to the door has been blanked out. On the opposite side, the car had an LPG gas cabinet fitted. This car internally was painted nothing but white, and so quickly garnered the nickname the Hospital Ward. In 1980, to supplement this car, BSR 2166 was rebuilt with Becklow windows and crest into service. It was not much more inspiring and instead had grey marbled laminex through the interior. So two very uninspired cars, which led to the introduction of the MFS, supplementary interurban cars, the favourite of many in preservation. So the delays with the interurban cars continued to compound. By this stage, only one batch of 2 car sets had been delivered and the pressure was still on. So these conversions followed the pattern of the 12-wheeled supplementary interurban cars. They removed the centre vestibule and created 2 new vestibules at the ends of the car. Seating was again reclaimed from steel electric cars. 6 were converted from FS cars and 1 from a BS car. MFS 2146 was rather unique in having original windows and original archtop doors used. Unfortunately, the only photo I've been able to find of it is this one, after it was burnt out at Gosford in, from memory, 1982. So this was the shortest lived of the MFS cars and the only one that didn't survive to preservation. The remaining 6 cars were all like MFS 2121 here, which had Becklow windows, much to the disappointment of enthusiasts everywhere. So we actually do also have an interior photo of these cars. Once again, grey laminex and white fiberglass. Absolutely thrilling stuff.
The seats are a nice colour.
Sorry?
The seats are a nice colour, but I'm not
Yes, lime vomit green.
Was the burnt out one believed to be arson?
It was assumed to be arson, but I don't know if that ever was actually formally established. Yeah. So, also around this time, testing systems are developing quite rapidly, and the dynamometer car is starting to be left in the dust. So, the CSIRO in November 1975 were testing fumigation of rice containers, and for some unknown reason, they came to the Public Transport Commission asking for a carriage in which they could accommodate their staff and testing equipment. BSR 2173 was chosen as the subject. It was fitted out with 5 sleeping berths, according to Carriageworks Assistant Manager Bill Casley. And in 1977, after having appeared to not re-enter service at all, it was rebuilt to become a laboratory test car permanently. The rebuild involved gutting the former buffet end and installing a Faraday cage. So those 2 gentlemen that we saw in the white jumpsuits, they were the CSIRO's test staff for the November 1975 tests. The buffet was likely converted to a kitchenette, and the remaining end of the car became 3 sleeping compartments and an amenities space for the test engineers. In this form, it served a wide range of testing duties, basically anything that you could imagine them testing. A notable use was that it was used for the XPT bogie trials. So here we see the car in 1977 just after being outchopped, and if you look very closely you can see the 2 CA bogies which I referred to earlier. This car also has the 1976 style L7 up on the letterboard. And so here we see the opposite side of it. You can see how many windows have been removed in order to accommodate the Faraday cage. And this is the XPT test trial, bogie test train trials. And a extremely rare snapshot from a documentary by Comment on the development of the XPT, showing us the inside of the Faraday cage. So that Faraday cage eventually proved to be a problem. The lack of windows reportedly resulted in several complaints of motion sickness, and as a result, the car was rebuilt without the Faraday cage. 3 additional sleeping berths were fitted in the other end of the car, and it received the new code VLI, which lasted about a month before being altered again to LIV 1865. It's believed that this time it was also fitted with 2 3.9 kilovolt amp Lombardini generators from Italy to power the onboard instrumentation. The earlier form seemed to require a power van to accompany it. Sometime after 1982, to resolve those issues with the motion sickness, 4 Becklot windows were cut into the car, 2 on either side, and that's how we see the car here in the 1990s. The last conversion which we have to cover is the out-of-gauge crew car, AH811. So by 1978, the SHG brake van that was being used as an escort car for out-of-gauge loads was tired and entirely unsuitable for the purpose. So withdrawn RBS 2176 was taken into carriage works and rebuilt. It received a kitchenette, living quarters and a full suite of Becklot windows. So here is the SHG brake van that originally was accompanying out-of-gauge loads. And here we see AH811 in its wonderful form with a full suite of Becklot windows. Basically any dime they could spare was kept firmly in the piggy bank, as you can see. All they have done is remove the seat cushions, built up the seat base and put a mattress down. You can even still see the panelling for where the original seat back, the seat back and cheek rests were located on the wall of the car. So yes, every cent that could be spared on this conversion was certainly spared. In 1995 it was transferred to Rail Infrastructure Corporation and probably became the last non-air conditioned locomotive hauled car in service in New South Wales. It was also repainted Freight Corp blue. It was used mostly on transfers of hot metal ladle cars between Newcastle and Port Kembla through the 1990s. Its final working was in January 2000 when it accompanied 3 hot metal cars being sent from the now closed Newcastle Steelworks over to Whyalla Steelworks. After this, the car went into storage at Dealek, and in 2008 it was sold to the Hunter Valley Railway Trust and sent up to Rothbury for storage. Today it now resides up in the Hunter Valley in a siding with other rolling stock belonging to the picnic trail. So with that, I'd like to conclude. Thank you everyone for listening. Anyone have any questions?
What I would like is if we can walk over and have a look at what people have bought.
With DCC and hopefully battery as well. I'm not quite sure how that's going to work out because I don't think it's ever been done. But, we'll have a crack at it. The second one is a Dapol 58XX Great Western tank engine. In case we have an accident. But you can hear it's, I think Chris did the sound file for it. It was 40 years ago. Next.
So this one's very much, I've used the presentation to progress forced me to my thoughts, and I haven't always wanted to think about it in detail because of the complexities of the room size, but it's been very useful, and hopefully other people will do something similar. This is basically building on John Armstrong's Gibbons and Druthers, or Druthers and Gibbons, given my options. Trains snaking through reverse curves, not a 20 by 9 metre shed, so that's probably a bit optimistic. Bus wires and electronics accessible. I haven't tried it. One of the things I want to test out is putting as much on the fascia as possible, some way of hiding it, but as little as possible underneath the layout. Minimum radius, as I mentioned before, it's the 13 is a consideration. The other one's a 60. Chatter on email groups says it can get round 62 inches, which I make it about 1.575 metres. So if I round that up to 1.65 as a minimum, that seems reasonable to me. Clearance, I just note that Gaucho Guild recommends that you have no protrusions below or within 4 millimetres of the wheel tread. So what did I choose? Well, a mix, a junction on the lower level, running up to a branch, up to the top with the terminus, and that was really inspired by the recent AMRM, the Gilmore station or junction layout. It is in a 12 by 12 room for HO, so it's bigger than the space I've got. But if you look at that track plan, a lot of the ends are scenery and could be curved around the room. And the staging, on the left you've got Cootamundra, which is the main line and is on the outside, so you get the maximum radius. And on the inside is the line to Batlow, and I could put smaller radii on the inside, and I know a 19 will go around a lot less than 6 foot. The station itself it's okay. It's not the most dynamic Gothic architecture. It's really just a very simple country station, but given my modelling skills, that's probably much more realistic than a model of Armadale Station or something. That's it. Thank you. Okay. John, thank you very much, guys.
Thanks, Nick. I think that was a great presentation. There's a lot of detail there, and the work that's done to work out how you make a layout fit and how to. That sounds great. I think we look forward to hearing part 2 when things start happening. A number of you may be familiar with that particular locomotive. If, like me, you signed up to a kit that came on a weekly or fortnightly basis about 7, 8 years ago. A fairly expensive way of getting a model of the Flying Scotsman, as it turns out, but of course you buy it week by week, so it doesn't seem so expensive. 6 months ago I decided it was time to get around and finish it off and paint it and so on. And so it is now finished. But I had done that, so that was done. So what are we going to do next? What's the next thing to do? On my bookshelf I just happen to have that book, which is the book on the 36. And that's the front of the book. That's the painting on the front of the book. And I thought, well, that's kind of nice. I kind of like that blue engine. I've never made a blue engine. I've made black ones, I've made green ones, but never a blue one. Now, I happen to have a second 36 kit, which I hadn't built. I bought two from Glenn some time ago, and I had built one, and that was finished in the more conventional colour schemes and so on. And of course, that's a bell pair, which is the way the kits were built. The kits were only built that way. But of course, as you saw from the photograph, that's a round top, which is the way the 36s were when they were first delivered. So there's not a lot of information about these. There's very few colour photos, except for one, which I didn't find at the time, which I'll mention at the end of this talk, because like all these things, you get right at the very end and then you find something and you think, if only I'd found that before. But there are a few photographs, and hunting around you can get a reasonable idea of what it looked like and the shape and so on. The bits that are different for the rear portion of the boiler. I also had the Greg Edwards drawing, not the no-scale version, but the standard HO1, which is helpful. Well, the obvious thing was to have a go and see if you could do it. And it's convenient that the way the 36 is constructed is the bell pair portion of the boiler is actually a separate casting. So put that casting away to one side and have a go at fabricating something up out of plastic card. Now, this proved to be slightly more difficult than I originally thought, because all the curves are kind of strange, because it sort of curves downwards in 2 dimensions all at once, and the material is not very strong and it doesn't really like being curved, so you end up using lots of rubber bands and glue to hold things together and some reinforcing brass strips. But the end result was something that looked, or appeared to look, something like what I needed. Now the cab was a bit trickier, as I had to use because the cab's quite a bit different. I had to use the existing etchers and try and modify those, and there is a bit of an error here, is unfortunately the windows are slightly bigger than they really should be, and that's largely because of the openings that are in the actual etchers. Now maybe I should have started and built a whole new cab all on its own from scratch. That might have been slightly more accurate, but I get to be a bit impatient. I like to work with what I've got, and so I went ahead on that basis. So we put it all together, add some primer, and the end result looked like this. Now to me, the windows don't look massively oversized, but they are a little bit. I'm certainly aware that they are. Now I have to paint it. Now, I managed to discover that the blue paint was called Garter Blue. This is 1925. This was made, this logo was painted, or the two logos were painted. SMS Blue Anniversary Edition looks like it would be about right. So we tried with that. And the end result, the light reflection's a little odd in that photograph. It's not as shiny as it appears there. The decals, because this was one of the things I worried about right from the beginning, where was I going to get some decals? Now the decals actually come from a UK company called Foxtails. I don't know whether anyone's used their decals. They produce decals for an enormous range of locomotives. They're absolutely brilliant products. And I managed to find one that was designed for a range of locos, which was exactly the right colour. Black and yellow, and there was enough on these particular card or the sheet of decals to just about, to do the job, including the curves that I needed. Very good decals, excellent, but very expensive. Decals end up costing about $75 for the decals, so they're mighty pricey. But they are a very good product. So, it was going to be DCC, sound and light, so what do we need? Well, in addition to the headlight, and sometimes there's a rear light, but in this case just a headlight, we need 6 functions covering the front white markers, front red markers, the rear white markers, the rear red markers, firebox illumination, and cab lights. Now, some of you may say, why do you need 6? What's wrong with putting the white and the red markers together? One's at the front, one's at the red, depending on which way the loco's. I never do that, and the reason is I like my locos to be able to turn the red lights off, because a loco at the head of the train does not have red lights at the back of it. It has it when it's running pilot, that's correct. So I've always liked to have white and red markers individually. They're both directional, of course, but they're individual. So that's how we get to 6. If you followed any of my construction articles, you'll know that I generally use ESU lock sound. Incidentally, I totally concur with the comments of Terry before. Zemo have a great range of products. The real reason I started with ESU lock sound and have stuck with them all over the years is 2 things. First of all, at the very beginning when I started, Zemo's documentation was almost non-existent. It was just terrible. I think you would agree. And it was really hard to work out how to do anything. Whereas ESU lock sound was very good. And the other thing that Terry said, and he's absolutely right, is when you find something works for you, you have a tendency to stick with what you're using. He's gone down that route, works perfectly for him, and it wouldn't for me if I'd have done an ESU lock sound. So, now this particular loco, the most obvious one to use is the 21 pin version, together with an adapter. Now, if it was going to be a commercial model manufactured in quantity, then you design a special printed circuit board so that you can put all the bits on to enable all the necessary interconnections. But for one-off applications, the simple solution, and of course I referred to this very briefly earlier this morning, is PCB Vario or matrix board is ideal. Now, I'm not sure how many other people use this. There's a great tool that's been available on the internet for, I don't know, 20 years at least, called VCAD. It's free, you can download it. It allows you to design matrix boards, it allows you to do all the circuit diagrams. I tend not to use it for circuit diagrams. I tend only to use it for layouts. So that's an end result of something. This is the board that's going to be used, or that is used in that 36 class loco. It's narrow enough to fit within the boiler, and on there you can see a range of resistors on the left-hand side which are associated with the lights at the front of the loco, and up the other end on the right-hand side you can see the connections for the motors, the speakers, and also the connections that ultimately go to the tender. There aren't any resistors, you'll notice there, because those resistors tend to be at the remote points. It makes this board a bit smaller. That board, when you build it up and when you put the decoder on the adapter board is underneath, the decoder sitting there on the top, and that's pretty much, if you line up from top to bottom, you can see relatively where the relative components are. Incidentally, the crosses on the diagram at the top, all the crosses represent a track that's cut on the other side. There's a bit of a magnification to see a little more how it goes together. And we were talking briefly this morning about stale lives and so on. In the case of this decoder, that's where they connect. Those 3 points at the top, it's connected there. They're just soldered on there. There's 3 connections. Now that looks after the loco, but we've also got the tender. I spoke earlier this morning about using the tower or lighthouse type LEDs in the tender, and this is the board that has those on it, and we can see the actual board there, not shown in this photograph of the actual LEDs, but if you see here you can actually see installed in the actual tender. And so of course the LEDs are on that view on the lower side, they point through, and they actually provide a physical connection to the tender. So you're actually using the LED not just to provide the light, but it's actually the physical constraint as well. There's also a very small PBA, which fits in the firebox, and that provides the firebox illumination and also the cab light. Neither of those LEDs are shown on that drawing. Now, in the past, I would have used a connector strip, the same connector strip that we've mentioned a couple of times, to provide the connections between the loco and the tender. But there's now a much better solution. There's a range of magnetic connections which you can get from 2 up to, I think it's 7 ways. For our purposes, 3 and 5 are ideal. 5 is the most useful because obviously 5 connections to the tender gives you the ability to use the tender for power pickup as well. You need 3 connections to cover the lights, 1 for the common, 1 for the red, 1 for the white, and 2 more provide a power back. So it's a 5-pole one. Now the main PBA fits in the boiler in front of the speaker, so it goes in from the front of the loco, and prior to putting it in place, all the connections are made to the chassis, etc. As you can see, and there's a diagram there where you can't actually see the board, it's inside, but that's the multitude of connections you end up with. Now, I mentioned earlier this morning when we were talking about LEDs, I haven't got a pointer with me, but the LED in the marker light, the one on the left-hand side is the most easy. You can see there's a sort of a white wire which is coming from it. They are a really good form of LED, a very small LED, but with a really strong braided wire, very effective, which can be stripped very easily because it has a thin insulation, so it's very easy to solder inside. And all of those connections are back to the board using that connector strip that we talked about before. Now the tender was also painted and lined, and so that really just about brings to the end. Now the obvious thing would have been me to have the model so that you could see it, but it's not finished. Not quite. I'm just assembling the last bits. The valve gear is proving to be a little bit of a problem with some friction on the side, which I've just got to resolve. I'm doing that now. It's not quite finished at this stage. Well, it proved to be a very enjoyable project, even if I did have some difficulty researching for the details. And one of the great ironies of life is just after I virtually got to the stage where you can see it's up to, I discovered this HO model from our session. I didn't even know this model had ever existed. It was apparently a brief time they sold it, which is absolutely perfect and would have shown me all the things I needed to know about the size of the windows and everything. Has anybody ever seen that model? I've never. Yeah. Okay, somebody's always got it. There's always the case. Anyway, I didn't even know that model existed. If only I'd known, that would have made the whole thing a little earlier, a little easier. Thanks. And the next forum's on Saturday, November the 7th.